Hi everyone, so this is part 2 in the creating a racing game in Unity, and in this tutorial we're going to focus on controlling all of the information we need to access and visualize our waypoints. Basically this waypoints container that we brought in the last tutorial. Now I went in and I shift selected everything and I removed all of the components that were on it. There was a mesh render and mesh filter. I just removed components so that the only thing left on was the transform component. Transform component, where it is in the world, is really the only information we're going to need. Last tutorial we also brought in our collision mesh optimize and our art mesh optimize. We brought in our nifty little 1960s era Ford Falcon. But today is all about the waypoints, and we're not actually going to play anything. We're just going to set up these waypoints visualizing the path racing line around the track, and the script that we're going to create to control the waypoints visualization and all that is going to be used by the player car, the AI cars, the game manager. It's going to control how the AI drives around the track. It's going to have control over current laps, 1, 2, 3, 4, current racing position against the AI. We're in 3rd place, 4th place, 5th place. It's going to be used for resetting the car when we, assume that we flip our car over. I can't even flip it. Something like Dukes of Hazzard style like that, and we need to reset the car. We'll use the waypoint rotation and placement data to reset that car in the center of the track and facing the proper way. We'll also, in the future tutorial, be setting up a wrong way indicator so that when you're driving the wrong direction down the track, it'll just continuously say wrong way, wrong way, wrong way until you turn around. We're going to use this waypoint controller to track that information, how to determine the angle of the waypoint's rotation around curves and things like that to determine if you're going the wrong way. So it's a pretty important script. So to get started on that, we'll go create folder, we call it scripts, and then on top of that right click and create a JavaScript. We call it Waypoint Controller. Hit enter, and we'll let it do its little compile thing, and we'll double click. JavaScript and C# are both really good languages for Unity that work well inside of Unity. Some projects I use C# and some I use JavaScript. A lot of the car stuff, it's just easier to work in JavaScript, though I could do it just as easily in C#. It's just personal preference, I guess. The only thing I would probably advise against is mixing the two, C# and JavaScript, in the same project. It's okay, as long as you could sort out, if you Google script compilation order in Unity, it becomes an issue if a JavaScript here cannot physically find a reference to a C# script within the same project, and that sometimes is an issue, but there are ways to make the scripts be able to see each other, so it's just a workaround. But if you're just sticking to one language, like all JavaScript or all C#, you're good to go. And so what I want to do in this tutorial is, rather than, I'm going to zoom in a bit, rather than hand typing everything, because I've already recorded this video twice before and it was 58 minutes, we're going to go through a little quicker, and I'm going to paste in the snippets, and then I'll write the code commenting for it, and it'll go a lot quicker. And that way I can explain each line and paste in each line manually. And we move along a little quicker so we don't end up with an hour-long video, and yet everything the script does is explained. So the very first thing, since I already wrote this script out earlier, I'm going to paste in here is at the very top, execute in edit mode. This is a nifty little built-in thing in Unity's scripting environment that will allow what's within this script to execute live in real time in the editor. There will be no need to hit the play button. It'll just work in the editor, and a lot of things don't. I'd have to research again, you'll have to Google it, but a lot of things sometimes don't work in edit mode in the editor, like I think physics forces and things like that. So, but for our purposes of just gathering up some simple transforms and showing gizmos for them, it's perfect. So that's what the execute in edit mode is. So basically, we need some variables, and there's only about 6 or 7 of them, so not too many. I'm going to paste in the first one. I've explained in other tutorials that variables have a type. So this type comes after the colon here, and it's an array list, which is like an array, but it's dynamic in size, and so you can resize it and add and remove items in real time from it, and it will grow and shrink in size to fit like a list in an array. So it's cooler than a regular static array. For ours here, we're going to use this, we'll just say, to easily access our Waypoint Transforms. That's exactly what we're going to use this array list for. There are public variables and private variables. This is private, so I will demonstrate the difference. Let's just type in public var, and we're not going to use this, but just values, and we'll say that they're a float, and we'll put brackets, which brackets tells Unity that this is an array of float values, an array. So let's see the difference. We'll let it do its compiling. Now we want to apply our Waypoint controller on this root transform object here, the container folder for all the little waypoints, because we're going to use this root to seek all the children inside of it. These are all the children. This is the parent root folder. So let's just drag the script onto it. Okay, you can also go add component scripts and add it that way, or you could go component scripts and that way. Dragging for me. So notice private var transforms array list, we don't see that. But public var values, a float type, we see it. It's public. So we can fiddle with these. Now this is an array. By default starts out at 0. We can type in any number in here and it gives us this many slots to plug in different things. You could plug in game objects, materials, lights, cameras, boxes, anything, but it just so happens ours is a float. So we could type crazy decimal point numbers like that, because we said public, so we see it in the inspector. It's a variable. The var is for a variable, and we're going to call this variable float. That's the name, just like this variable's name is transforms, and we're going to say that array is called float, is a type float. All the array values in the array are going to be floats. So that's how that works. We're not actually using that, so let's get rid of it. But that should explain that we don't want to mess with this transforms array list here, so we make it private. We don't want anyone fiddling with that. The next line I'm going to paste in is another private variable, so we're not going to fiddle with it. The script is going to determine this, and it's going to be called first point. It's a vector 3. Vector 3 is real simple. Think of vector 3 as x, y, and z. It's a point in space. So the x, y, and z, or the vector 3 here is 0, 0, negative 13 for this point. It's also an axis. So vector 3, this is the z vector, this is the x vector, the y vector. It's a direction and a position. So it's pretty. These are vector 3s are pretty nifty. So first point is just going to be, well, we store our very first waypoint here, so we can loop around a path. Let's store the very first one because we're going to have a series of them and loop around them. So the next thing we want to put in our script here, I'm going to paste it in, distance. It's a private variable too. We're not going to play with it. The script is going to determine the distance itself. And distance is going to simply be used to if I could spell right, used to calculate the distance between waypoints. It's just how the script's going to keep track of the literal distance value between point 0, 1, 2, 3, and so on and so forth. It's going to know the distance between each one. And this will become really important for position checking, like who's in first place, because what we're going to do is say, well, the cars are physically here, and maybe the AI car's ahead of you, so he'll be at a higher waypoint number, the index. He'd be at waypoint 2 and you're at waypoint 1, so he's ahead. But sometimes you're on the same waypoint. You're both on waypoint 2, so how do we gauge who's ahead? Well, what's the distance between waypoint 1 and 2, and who's closer to waypoint 2 versus waypoint 1. So if that makes sense, we need to keep the distance between each of the waypoints. So the next variable I'm going to plug in here is another private variable called TempTrans, and it's just basically short. It could be TempTransform, doesn't matter. It's just saying this is a temporary reference to a transform, and it is a type of transform. And we just say, I'd say it's a temp holder for a transform. We're going to use it for purposes in a minute. Okay? And as well as the actual physical transform temporary, we need to temporarily store and index the number, like what is an actual integer. Int is short for integer. Oh, 1, 2, 3, or 4, unlike a float that can float from 0.01 to 0.9 to 1. An int just can go 1, 2, 3, 4, -1, -2. So we want to temporarily store an index number, and to explain that, we'll just say, well, this is a, oh good lord, a temp holder for a waypoint index number. So it's an index number for a temporary waypoint. Okay? And the next variable, we've only got 3 more variables to go, so not many. Another private variable, and this one's total transforms. It's also an integer, so it's a count, like a solid count. 1, 2, there's 27, there's 45. And kind of as it implies here, it just says this is the total amount of transforms or waypoints we've grabbed. The total amount of waypoints. Okay? Think of them as transforms too, because it's really all they are. Okay? And then another variable, private, current position. Current pos, it's a vector 3, so it's a point around the track. What's the position? You know, in 3D space, I'm trying to zoom out, Unity's thinking. Where's the position of this waypoint? The current one. Could be anywhere around this track. Okay? Oh, my spelling. Okay, and then our last variable will be last position. Right? Same thing. Vector 3. Last passed by waypoint position. Well, let's not say passed by, because this doesn't really have to do with the car. This is the last position as this script itself will be moving through all of these transforms, 1, 2, 3, 4, along the track as it's moving physically down and monitoring itself. This will be the last position it was at. This would be at the current position. This script is basically going to allow the waypoints to be intelligent about themselves and where they are. Okay, so let's move on to our first function, and we're going to use function start. Function start's pretty simple. It's a built-in Unity function, not a custom one we create. And when you hit the play button, and that play button turns blue, the start function has been executed. But after that, after everything that's inside of these brackets is executed in this function, it's done, it stops. Whereas function update, everything inside these brackets occurs every single frame of your game. And that's advantageous for things like keyboard input, mobile touch input, controlling and fading animations and blending animations, and things like forces on physics and things like that that need to happen every single frame. So what we want to do right when the scene starts up is we're going to call a custom function. And that custom function we're going to create down here is called Git Transforms. And we'll comment the code by doing 2 / and then making some notes. And we'll say make sure that when this scene starts up, that we grab all the transforms for each waypoint. That's it. That's the only thing that's going to occur inside of start one time. So right up front when the scene starts, we're going to go and grab all of those transforms for the waypoints. Alright, so we're not going to use update, but we're going to use another built-in function called onDraw Gizmos. And opening bracket, closing bracket, and everything we want to happen inside of those brackets in here. On-draw Gizmos is basically a built-in Unity scripting environment that allows you to have gizmos draw lines, cubes, spheres, wires, all kinds of things. They don't, let me try to pull my window out here, they do not show up in the game view. They only show up inside the editor view here, and they're very handy. I mean, you've definitely, if you've ever seen any Unity projects or tutorials or demos, you've seen gizmos. This is actually a gizmo right here, this transform X, Y, and Z colored thing. This is a gizmo being displayed in the editor. So when we use on-draw gizmos, that allows us to create custom gizmos to use. So we're going to paste in our first line here, and this is just a sanity check, and we're asking a question right when this starts. Okay, we don't have to call on-draw gizmos because it's built in, and it works like update function does. This on-draw gizmos will be occurring in the editor in real time. Okay, so we're asking a question. We're just saying if the transforms equal null, then run the function GetTransforms. Okay, so if this is null, then run this function, go grab all the transforms. That's all it's asking. If this array list is empty, you can think of null as empty. So let's look back. Alright, so here's what null looks like. Just like that. None. Empty. Nothing plugged in. That's null. Very simple. So if it's empty, if there's no transforms in there, then get them. So we can comment that. We can just write, if we don't have any transforms for waypoints, then go grab them all. That works out. Okay. So the next part, we're going to ask another question. After we've asked, are they empty? Should we go grab them? Yes, if it's empty. The next one we ask is, alright, well, if the count is less than 2, then return. Now, count is just a built-in part of ArrayList, and it just looks through the list, the array of all these transforms, and it counts them. And it says, well, if that count is less than 2, then return. And return is just a very simple part of a script that literally says, return to the top of this function and start over. Return, start over. So it's actually asking the question and saying, if the transforms count, the amount of waypoints we found is less than 2, go back and look for them again. Go back, look for them again. You didn't get me enough. And basically, we do this to make sure that we have more than one transform in our list. Otherwise, we can't draw lines between them. It's that simple. If we don't have at least 2, then there's no way for us to draw these gizmos. It's going to draw a neat little path around the track. So return. So if the count is equal to 2 or greater, then this return will never get called, and we'll just keep continuing down properly. So I'm going to paste in 2 more. Okay, and so now we've already figured out that the count amount of transforms is at least 2. So at that point we say, let's take that temporary transform up here, a temp holder for the transform, and let's say that it's equal to the very, very first transform in the array list. The 0 position is the very first one. If it's 1, that's the second position, third position. For some odd reason, it starts counting at 0, which is a little odd in arrays. You know, they don't start at 1, they start at 0. So it's just saying make the temporary transform the very first one it finds, very first transform. So that will actually be this first, that would end up this, waypoint 0. And then we say the last position will equal the position of this temporary one. So basically saying the last position is going to equal the position of the very first one it found in the array. And so we can comment that and explain it a little better and just say, hey, this is going to draw our path around the track. First, let's grab the position of our very first waypoint. We'll comment another line so that the line has a starting point. Yeah, makes sense, right? Okay, we need another little variable, and this is going to be a temporary variable, which is different than the variables declared outside of a function up here. This is declared inside this function, so it's something that's going to be modified, created, and changed right here. And we're just going to say this is a temporary point t. It's a temporary transform. This is a type of transform. It's going to be equal to that temporary transform. Okay, we're actually going to use this to point waypoints towards each other, and it'll make sense here in a second. We just say comment out and we say we point each waypoint to the next so that we can use this rotation data to find out when the player is going the wrong way, or to reposition the player after a reset. Perfect. Then we can say this is the temp reference to the transform we want to point towards, and that's what point t is about. It's going to be a very temporary transform, changing constantly depending on where we are around the track. Okay, let's paste in the next thing we want to do. We want to say that the first point is going to equal the last point. And to explain that, we'll say this is the first waypoint, and we want to store it to the last position so we can close our path later. That'll allow us to make the path completely come to a loop and close itself instead of being an open loop here at the start point. Okay? I'm going to hit Control S and save. Now the next thing we're going to do here is Gizmos color. And we're inside of the onDrawGizmos function, so we can call Gizmos color. And it just takes the color property of all gizmos that are being drawn inside of this, and it's saying let's give it a new color. This is red, this is green, this is blue, and this is the alpha. So right now our Gizmos colors will be pure red and 100% visible. 0 alpha would be 0 opacity, so it would be invisible. Okay. They would have full transparency, whereas this is solid. So you can kind of play with this and be like, let's make it half transparent or whatever. For this purposes right now, we will leave it full red. So it's just going to get some colors for us. Okay, so right after we set the colors for all gizmos we're drawing, we're going to do a for loop. And a for loop's pretty simple. You can Google it and look it up, but it just is going to loop through a group of items, and it's going to basically be like a counter. It's going to count up until we reach a certain predetermined amount, and then it's going to stop counting. So what it's saying is for the time that this is going on, let's create this temporary variable called I, and it's an integer, and it's equal to 1. And let's say, all right, well, while the I is less than the amount of waypoints we have, our ArrayList, our transforms count, then add 1. Keep adding 1 to them. It counts up while that I keeps staying less than the amount of transforms. Okay? We need brackets for this because it's going to execute something. The for loop will execute something within the function itself. So we want something to happen inside the function within it. And we just want to say we've looped through, we've said, oh, I'm too far over. We've looped through all of the transform counts, counted them all up, found all of them, and we want to say let's make that temporary transform reference we had earlier, let's change that to transforms I. Now, in simple terms, what that means is that simply means this variable I here, it's counting up. Let's just set that temporary transform to the next one it's counting to, one of the individual ones it's counting up to. Okay? And just simply, to comment it, we'll say loop through all of the waypoints and draw lines between them, because that's what we're going to do inside of this area here inside the brackets in the for loop. We found the temporary one. Now we want to find the current one, so we're going to say the current position is that temporary transforms position. So that's the one we're currently at. Okay? We can comment that and just say grab the current waypoint's position. Not the transform, but its position. Where is it? And then when we have that position, let's do something with our gizmos. We're going to say gizmos, because we're in the onDrawGizmos function. Let's draw a line between the last position we're at and the current position of that temporary transform in this loop through. It's going to draw a line between the last one and this one, and that's what we'll say. Draw a line between the last waypoint and this current one. Pretty easy peasy. And we want to go in here and do gizmos and draw another cube, and this is going to be draw our very first waypoint. That first waypoint is kind of a special case because it's the very first one that everybody is tracking, the AI and the players. So we're going to draw a cube for it, and we're going to say it's the first point. And if you remember, when we commented that, first point is a position that stores our first waypoint, so we can loop around. We're saying draw a cube at that first point. And then we're going to do a vector, a position here, and we're going to say make that cube 2 in X, 2 up in Y, 2 in Z, and this is basically its scale. That's its size. So the cube will be 2 units, 2 units, 2 units. We can make it larger or smaller with that. Let's continue on. We're going to draw another cubes, and rather than it being the first one, we'll say draw all other waypoints. Okay, so this draws our first one. This will draw cubes for current pass, which will be all of our other waypoints. So we'll just loop through, and that'll be it. Draw all other waypoints. Now we want to get some rotation. Okay. Remember we created this pointing transform earlier, and we said we can use this rotation data to find when the player is going the wrong way. It's going to rotate and turn and point them. That's what we're doing. We're grabbing that point T, that temporary transform, and we're giving it the LookAt function, which is a built-in in the scripting environment in here. It basically makes a transform rotate to face another transform. And we're saying take the temporary one and make it face and turn to the current one. So basically they're just going to rotate and turn and look at the one, let me put some spaces in here, at the one before and behind it. So we can comment that and just say point our last transform at the latest position. Okay. We're going to paste in the next bit we need to do inside this for loop still. We're still looping through and checking current, just constantly checking through all the transforms. We're going to say let's make the last position the current position, and basically that's in common sense terms that the last one you pass will be the current one. You've just come up on the current one, and so we'll say update our last waypoint what am I thinking? Waypoint to become this one as we move on to the next. There you go. And then the very last thing we want to do is back to that pointing transform, that one that's rotating. We just say, hey, it'll be equal to the inside the transforms array list. It'll be equal to each individual one, the I, which when we're where'd I go? In this for loop, That's the I represents each individual one inside of the transform. So do the pointing to every single one that it found inside the loop. And that's it. And I'm going to remove some spaces. Oh, we didn't comment that one. And I'll just say update the current pointing transform, which in the for loop, everyone's going to become the one it's currently working on. And then outside of the for loop, because this is executed everything inside of these, but we still want to do it inside on draw Gizmos. We still want it updated with the rest of it. Let's just say, well, we're not typing. We're pasting. Let's just say Gizmos draw line, current position to first point. And I'm going to write what that means, and that just means close the path and visualize the line around the entire track. So that's what it's doing. It's going to draw a line between all the current positions and then the very first point, the very first waypoint. So there you have it. Easy peasy. So that's it for our on-draw Gizmos. Now we called a function up here called Git Transforms, and we're going to hit save and go back to Unity, and we're going to get a bunch of little errors. Unknown identifier Git Transforms. That's an error because we're asking for a function that doesn't exist. So let's copy it, go down, and write function, and paste it. Okay? And then some brackets because we want to execute some stuff inside of them. Okay? So let's okay. So I'm going to paste this in. Now remember, going back, we called this in start. So this happens immediately when the scene starts up. It also happens in the on-draw Gizmos every frame if there are no transforms found in start, but some are added maybe later on. Go back and get them again. So this is the Get Transforms. So in here is basically where we're finding all of this transform component for each one. Okay? We're going to seek every single one, and then we're going to fill up this array list right here with all of the transforms. So we say, alright, so the transforms array list is going to equal a brand new list, a dynamic one. We're going to create it right here, and we're going to assign some stuff to it. So we should probably comment that, right? Store all transforms for waypoints in the array list. Okay, I'm going to copy in the next section we need to do, which is another for loop. We just saw that one up there, and you know from before it just means loop through some things. So it's saying let's create a temporary T, which is just going to be a temporary reference to the transforms. It's a type of transform in transform. So it's just a little single temporary reference to every transform in the array list. And then we're going to say, as we loop through the transforms array list, add T, add a transform. Okay? So what's happening here is this script, Waypoint Controller, is on this transform right here. It has a transform. And so what it's saying is loop through, okay, in the transform, loop through and find all of the children transforms, all of these, everything that's a transform inside of it. Okay, so we can type that and we can go now go through any transforms under this transform so all child objects can act as waypoints in our array list. You couldn't comment any better than that. The add function here is one of the neat functions of an array list. We can just say go through the array list right here and add this, the T. Add the single object, but it's going to keep looping through. That's the for loop, loops through, so we're going to add multiple. And then once outside of that for loop, let's just say total transforms, which was this integer up top where we track the total amount of things we have, equals transforms count. Once we've looped through and found the full count of all these transforms, then make that number that amount. So we found 27, total transforms would be 27. Okay, so the next thing we need is that's going to loop through and find all of our transforms. We need one more function. Well, one other one after, but it's very small. And it'll be called function get waypoint index, and we want brackets to open, brackets to close, because we're going to have some information in there. Okay. And so what this is this is a function that's going to be used by the game manager. An external script outside of this one in the world is going to reference this to get an index, the number of a certain waypoint in a specific spot, and its transform. So this is going to be used elsewhere. And what we're going to do is we're going to run another check. And okay, put some nice spaces. We're just going to, this is the same check we do up here in this exact check. We can copy and paste this at the very top of OnDraw Gizmos. And the reason that we're repeating it down here is because this getWaypoint will not be called inside of this Waypoint Controller script. This is going to be accessed by the game manager outside. So we do need to check again. Are all the transforms there before we need to use them and get this, before the game manager is going to need to get an index? If not, grab all of them. Grab them if they're empty. Okay, and so we need to do another check because an external script is going to be accessing this. And we're going to say if the index is greater than the amount of transforms, then return empty. Okay, don't do anything. Just return null, return empty. And so we say first off, let's check to see if this index is higher than our waypoint count. Okay? If so, return null, which will be handled in, we'll just say another script for right now. It'll be handled in the game manager if this returns null, so it'll error out with a warning from that. We're not gonna try to manage that control from inside the Waypoint controller. So if the index is not greater than the transform count, then we don't need to return. We can actually tell the game manager to return the actual index inside the array list of that waypoint that it's looking for. Which one are you looking for? You know, we'll see when we work on the game manager script why it needs to get the current waypoint, you know, and its index, its number. So we're saying right here, when the game manager asks this, we're saying, well, if you have all your waypoints, we're good. And as long as that index isn't greater than the count, which means something's wrong, as long as that didn't happen, continue on down and give me the information about the current trend, the index in the array list. That's really all it's doing. And then the very last thing is another function, and it's very tiny, and I'll type it. And it's called function get total, and it'll be an integer. And we need closing brackets on it. And we'll just say return total transforms. And we'll enter and do spaces. And basically this is another function that's not going to be accessed or called inside this script. It will be accessed and called from the game manager or the AI or the player. And all it'll be doing is looking for an integer, a number, and that number will be the total amount of transforms. How many waypoints does this track have? It just says, hey, return to me the information on the total amount of waypoints. So let's hit Control S or File, Save, and return. And it already updated for me pretty quick. And now you will see all of our neat waypoints, and they have no render on them. Okay, and even disabling them does not disable the gizmo. And we can go in and do neat things like, it's pretty neat moving transforms, huh? And if we go in wireframe mode, you can see that I'm able to actually move it, and the path visually updates in the editor. Okay, I'm going to zip those back. If you think they're too intrusive, then we can go back right here where we do the draw cube, and you could go, I'm going to go 1, 1, 1, and this is just setting the scale. Okay, and now they're much smaller. Okay, and that's much more probably legible. Also, if you don't like the color and you're a fan of, let's see, red, green, blue, if you're a fan of blue, let's put a 1 in the blue slot and we'll wait for it. And actually, that's a hell of a lot more readable. So there we go. Our Waypoint Controller script is on the object, and we have everything we need to visualize our waypoints, and we have everything we need going through and getting all of the transforms. We're getting their index. I'm going to test something out. We can go in here. I did this little thing here where you can look at a script, and you can look at an entire game object in normal mode or debug mode. And I'm wondering, well, we don't need to hit play, actually, because we put execute in edit mode up top. It's already working. Look, total transforms 75. And some of these other things like the temporary index and stuff like that, that won't be updated until the game manager is working with the script. So there we go. It tells us we have a total of 75 waypoints in there. Pretty neat. So basically, I know it took a little bit of time working on the script, but it had to be done because this Waypoint Controller script is used heavily in the positioning and respawning and race position and lap counts and things like that. So in the next tutorial, we will move on to our game manager script. We won't be driving a player car just yet, but we're going to work on the game manager object. And so I will see you guys in tutorial 3.